Hello everyone, today I am going to show you how to label hybridization in molecules. So what does that even mean? When we say label hybridization, we're just figuring out whether an atom is in three ways. It can either be sp, sp2, or sp3. Now, it might sound complicated, but here's the general idea. Electrons repel each other, so they want to move as far away as possible. To make that happen, atoms mix their S and P, they will mix it into these hybrid orbitals. So it can either be sp, sp2, or sp3, so that the electrons stay happy and they are spread out. And also I want to mention also that lone pairs count too, because they take up as much space, sometimes even more than bonds. So when a teacher is asking what's the hybridization of an atom, what that teacher is really asking, how many orbitals did this atom mix together to make bonds and hold lone pairs? To that, we can respond with, it can either be sp, sp2, or sp3. My three-step rule that you can use to hopefully help you to label hybridization every single time is step 1, pick the atom you want to label. Remember, it can either be sp, sp2, or sp3. Next, you want to count the regions of electron density around it. For a single bond, that'll be 1. For a double bond, it'll be 1. For a triple bond, it'll be 1. And for each lone pairs, it'll also be 1. Step 3, match the number to the label. So if I have 2 single bonds, then it'll be 2 regions and it'll be an sp hybridization. If I have 3 regions, if I count maybe 1 single and two double, that'll be an sp2 or hybridization. If I count 4 single bonds and I have 4 regions, that'll give me an sp3. Right now, it won't make too much sense, but I just want to give you the general rule so that you can solve that each and every single time. So let's work through some examples. Hopefully it'll make sense. So example 1, let's take CH4, which is a methane. And let's put our general rule right here so we can always look back to reference it. Okay. C is connected to 4 hydrogens, as denoted by CH4. Let's label this. Carbon has 4 single bonds. And remember, each single bond counts as 4. So carbon has 4 single bonds, which counts as 4 because each single bond will count as 1. 1 times, and it has 4 bonds, it'll be 4. Looking down here, if there are 4 electron density regions, that'll give me an sp3 configuration. Let's recap that again. Carbon has 4 single bonds. And we said for each single bond counts as 1. So 1 times 4 is 4. Coming down here, 4 regions is sp3. Another way you could do this, and a way that I typically do this to work even faster, is for each bond, I will just simply notate it. So sp1, p2, p3. Again, I'll show you that again. Because it can only go up to sp3, I will count the bonds surrounding it. So sp1, p2, p3. Either way will work. You can either use option 1 or option 2, which I've highlighted in a purple pen. Let's do a couple more examples, and hopefully it'll make sense. Example 2. Let's go ahead and let's take ammonia, NH3. Nitrogen is bonded to 3 hydrogens. The hybridization of the atom that I want to pick is nitrogen. Okay, let's count how many bonds nitrogen is bonded to. I'm so sorry. Please forgive me. It's NH3. So sorry about that. Nitrogen has, and 2 lone pairs. My bad on that. Nitrogen is bonded to 3 bonds, and it is bonded to 1 lone pair. We stated that in our checklist, first you want to pick the atom you want to label. I want to label my nitrogen. Perfect. Step 1 complete. Step 2, it says count the regions of electron density. So for each single bond will count as 1. I have here 3 bonds. So I'm going to do 1 times 3. It'll give me 3. Also, my lone pairs here will count. So each lone pair counts as 1. So I have 1 lone pair, and that will count as 1. So in total, I have 3 plus 1, which will give me an sp3 hybridization. We can either use the second technique, which you just simply label the bonds. So S, P1, P2, P3. Remember to count the lone pairs as well. And that's another way to do it. All right, let's go to example 3. Because the more practice, the better. And hopefully, once you do so many of them, it'll start to make sense. Let's do H2O, which is simply water. Oxygen is bonded to 2 hydrogens, and it has 2 lone pairs. First, step 1, label the atom you want. Label the atom, and I know what atom I want. It is oxygen. Okay, now let's go to the second step of our rule, which is label the electron density. Label regions of electron density. This includes single bond, double bond, triple bond, or lone pairs. Regardless, each one of them counts as 1 electron density. Okay, let's go ahead and label it. I have 1 single bond, and I have another single bond. That counts so far as 2 electron densities. And we cannot forget my lone pairs. Counting that makes a total of 3. I have 3 electron region density. Okay, now I have 3. Now I'm going to go to step 3, and remember our list where it said that match the number to the label. So here is my label. I'm simply going to copy that, paste here. I have 3 electron density, and that matches right here, which my hybridization is sp2. Another way we could do it is simply just label it directly. So this is sp1, p2. There are no more bonds and there are no more lone pairs. That's simply my answer. Again, I'll show you that again. For a shortcut, is simply here is oxygen is connected to a hydrogen, S. Oxygen is connected to two lone pairs, that'll be P1. Oxygen is connected to a hydrogen, that makes it sp2. So the hybridization of water is simply sp2. All right, let's go ahead. I'm going to provide some additional examples and you'll try them out for your own. And hopefully, if you still need help, I will provide the answers and work through it as well. So here are the other examples I'd love for you to try. So let's do C2H4. Another one, let's do BF3. And lastly, the last one I'd love for you to try out is CO2. Go ahead and give it a try, and hopefully you'll be able to get through them and figure out the hybridization. Okay, let's go ahead and do the first one. The hybridization of C2H4 is, there are two carbons. It is double bonded to each other with two hydrogens on each carbon. Firstly, let's label the carbon to notate its hybridization. Let me highlight carbon 1 as pink and carbon 2 as green. So let's begin with this one. Carbon 1, first you want to count how many bonds is it connected to and or lone pairs. So remember how we said up here, you want to label your regions of electron density. So if it's a single bond, it counts as 1. If it's a double bond, it also counts as 1. If it's a triple bond, it counts as 1. And if it's a lone pair too, it counts as 1. So let's go ahead and label it. So this carbon is connected to two double bonds, which counts as 1, plus it is also connected to a hydrogen here and a hydrogen here. That counts as 1 plus 1. So 1 plus 1 plus 1 is 3. Now let's go ahead and let's see if I have 3 electron densities, if I have 3 regions, what will that match up to? 3 regions is sp2. So my answer is for carbon 1, the hybridization is sp2. Again, let's do that shortcut notation if that helps you as well. sp1, p2. Okay, now let's do the second carbon. Let's do the second carbon and let's figure out what its hybridization is as well. Let's count the electron density regions around it. So let me just erase that. Just so that my highlighting will not be too much and overwhelm anyone who's watching this video. Carbon 2. It is, let's count the electron density around it. So carbon is connected to 2 double bonds, a hydrogen, and a hydrogen. That makes it a total of 3. 1 plus 1 plus 1 gives me 3. Because remember I said double bond only counts as 1, as well as single bond. 1 single bond, another single bond, and double bond counts as 1. So adding them all up together is 3. And then if you look at, again, 3 regions is sp2. We can count sp1, p2 if you want to try that shortcut as well. So both carbon 1 and carbon 2 is sp2. Let's go ahead and let's work with, let me separate this slightly, BF3. BF3. B is connected to 1 fluorine, 2 fluorine, 3 fluorine. I want to figure out the hybridization of boron. Boron is connected to three atoms, 3 single bonds. Each single bond is connected to 3 single bonds. Each one of them counts as 1. That gives me a total of 3. 3 regions, again, recap, 3 regions is sp2, giving me boron has an sp2 hybridization. Okay, and then if we want to do fluorine as well, let's fill in the electron pairs. Let's do that as well. Fluorine is connected to 1 single bond, plus it has 1 lone pair, 2 lone pair, 3 lone pairs, making it a total of 3. Gives me 4 regions. 4, if we look up here, 4 regions is an sp3 hybridization, giving me fluorine has a hybridization of sp3. And because these are all identicals, and you can try it out for yourself, if I fill in these electrons, fluorine, all 3 fluorines have hybridization of sp3, sp3. Boron has configuration of sp2. Let's do our last example. C is double bonded to O, which is also double bonded to O. Let's figure out the hybridization of carbon. The hybridization of carbon, if we label it, is connected to 2 double bonds, but each double bond counts as 1. So 1 plus 1 gives me an electron configuration. It gives me 2 regions. 2 regions is sp. So carbon in the middle has a configuration of sp. Let's take this oxygen and let's fill its electrons. Oxygen 1, which is identical to oxygen 2, but we could still write out both. This oxygen is bonded to only 1 single bond, so that counts as 1. It has 2 lone pairs, so 1, 2, so it has 2 plus 2 gives me 3 regions of density. And again, we said if there is 3 regions, it'll give me a configuration of sp2. Let's go ahead and label that sp2, sp2. If it helps you, you can also try the notation which I've stated before. So sp1, p2, and that matches up to oxygen 1. Again, we can try that again, sp1, p2. And those are all the potential bonds that oxygen can bond to, which also matches to sp2. Let's try carbon. Carbon, sp1. That also gives me sp, because there's an imaginary 1 up there. Okay, I hope this helps. If you need any more help, you can definitely find more practice problems online, and hopefully I hope this video was helpful in any way. Thank you.